Okay, this is our last question. So it starts by talking about extracting metals, and they ask about sodium. Sodium is a reactive metal. In fact, it's the second on your list. So how do I extract sodium from its oxide? I need electrolysis. Okay. Part B asks you for why you need more energy to extract sodium from its oxide than iron from its oxide. Now, we know that sodium is more reactive than iron. Okay, so then what? Okay, so because it's more reactive than iron, so it forms stronger ionic bonds. Hence, it requires more energy to extract sodium from its oxide. Okay, so that's your answer. It's more reactive, hence it's got stronger bonds and requires more energy. Part C. You've got the reaction of 4 metals with HCl, and they want you to put the most reactive first. So most reactive will be explosive. Then you've got a rapid. Then you've got a moderate. And then lastly, you have no reaction. So let's write it down. Got E, D, G, F. Okay. Then we go on to part 2. If G is zinc, moderately quickly, zinc. Find D. D reacts rapidly. So rapidly, I've got 1 or 2 choices. Preferably magnesium. Okay, because explosively you will have sodium, potassium, maybe even calcium. So magnesium fits your answer perfectly. Part 3. Explain why metal F will not react with acid no matter how hot or how powdered the metal is. Now, there's no reaction anyway. So, what does it tell you about F? F is an unreactive metal. Probably copper for the matter, or silver or gold. Okay, now, last bit. We've got a reaction of carbonate with acid, producing gas. Plot a graph of mass against time. Notice the mass decreases as time goes by, and it stops at time 2.5. So let's just draw an estimate. I don't have graph paper, so I'll just estimate for you. okay, times 0, mass in grams, time in minutes. My graph will look something like this. Okay, it should be a straight line. Okay, you need to fill in your axes. Please put the starting point, end point. Okay, this is supposed to be done on graph paper. Now, if you repeat this experiment using same volume of higher concentration. Okay, on the same graph paper, sketch the graph which you would expect and label it as A. It's got higher concentration, so you expect the reaction to be faster. Faster reaction means my graph would have a steeper gradient. So I'll just make notes down here. Faster refers to steeper gradient. So let's plot it in again. Steeper gradient would thus be like so, and then I end off a bit earlier. Okay, and I label this A. So part 1, part 2, done. Part 3. How the rate of reaction is affected with decreasing particle size. Back to our VIP notes. Smaller particle size gives us a larger surface area for collisions. Okay, so larger surface area for collisions, then what? Okay, decreasing particle size gives you larger surface area for collisions. For what kind of collisions? So larger surface area, more effective collisions, so your reaction becomes faster or your rate of reaction increases.